Yeah. Yeah, good afternoon all. So myself, I'm Vijay. Like I hold 18 plus years of experience, which includes nearly 8 plus years of experience in big data, Hadoop and Spark environment. So as part of today's demo, I'll be covering the following topics. What is big data? Why Hadoop? Drawbacks with the current databases. Hadoop and Spark advantages. Hadoop and Spark job market, right? Yes. So starting with what is big data, right? Big data, the name itself saying like huge volumes of data, right? It's like huge volumes of data. Currently, how the data is getting stored, So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes.
It's clear.
Yes, sir.
And thank you. So like you should have seen KBs of data, MBs of data, or GBs of data, right? KBs, MBs, or GBs of data are TBs, petabytes, exabytes, zettabytes, ottabytes. From TB onwards, we say like big data, huge data, right? They have seen KBs or MBs or GBs or even TBs of data, right? But petabytes of data. Do you think like petabytes of data is it getting generated in the current real world? If so, examples of petabytes of data generation. 1 petabyte equal to 1024 TBs, right? Already 1 TB is a large storage unit, but 1024 TBs forms 1 petabyte. Examples of petabytes of data generation. Talk about any banking sector, like if you talk any example of any bank like SBI, it has got hundreds of branches within the city. It has got thousands of branches, right? It has got hundreds of branches within the city, and it has got thousands of branches within the entire state, lakhs of branches within the entire country, right? So lakhs of branches having millions of customers in each branch. So millions of customers making multiple transactions per hour, per day, per month, per year, right? Each and every transaction has to be stored. Huge data is getting generated, right? Not only like this banking sector. Take example of any like social media like Facebook. Take example of Facebook, right? Facebook it has got users throughout the world, millions and billions of users for Facebook. In a minute, how many posts and videos are getting circulated? What should be the storage capacity to store all that posts and videos? What is the data generated by Facebook in a minute? Huge data, right? Not only like Facebook, right? We have got many applications which are generating huge data, Examples of huge data generations. Applications generating huge data, right? Yes. If I take 1 minute transaction, right? In a minute, what is the data generated by Facebook in a minute? Data generated by Twitter tweets. Data generated by Facebook in a minute. Data generated by Google queries. Everyone querying in the Google, right? What is the data generated by Google, right? And data generated by YouTube videos upload. YouTube videos, right? YouTube videos upload. What should be the storage capacity to store all the videos? Email or Gmail messages. Millions and trillions of people has got this email messages. What should be the storage capacity to store all the messages? And even just now I was talking about the bank transactions. Bank transactions. Or even if you talk about the telecom transactions or e-commerce Amazon and Flipkart transactions, right? E-commerce transactions. So everywhere we see like huge data is getting generated, right? Not in terabytes, in petabytes of data. Google and an average generating more than 300 petabytes per month is generating more than 300 petabytes per month and an average, right? Means 300 into 1024 TBs and an average, right? Data generated by month. So currently we have got databases for storing data, right? Like Oracle, MySQL. Observe here, we have got databases like Oracle, MySQL, DB2, SQL Server. Currently, we have got databases like this, like for storing the data. It's used for OLTP, online transactional processing. They're used for online transactional processing for day-to-day operations. And they are specialized databases like Teradata, Netija, Vertica. Teradata, Netija, or Vertica are the specialized databases. They are used for data warehouse purposes. They are used for online analytical processing, right? Analytical processing. So these databases are special databases that can handle data in GBs of data, right? They can handle GBs of data. But Teradata, like specialized databases which are used for data warehouse purpose, they can handle uh, TBs of data. But huge data, unlimited data storage is not possible with these databases. But in petabytes of data, storing petabytes of data is not possible with this databases for huge data storage. Yes. So, so as a solution to all these storage level problems, right? We have got a framework called big data Hadoop, right? Which can store huge data or unlimited data, which can store huge and unlimited data storage is possible. But see how the data is getting generated. If we talk about the data generations from the last 50 years, right? Yes. This is the data which got generated from the last 50 years. Assume this is the data which has been generated from the last 50 years. From 1974 to 2024, right? Yes. If we observe from, if you observe this data generation, right? From the previous 40 years as compared from the last 10 years, nearly 80% of the data what we see, right, has been generated from the last 10 to 15 years, and previous only 20% of the data has been generated in the previous 40 years from 2074 to 2014. But what is the reasons for huge data generation? Reasons for huge data generation, especially from the last 10 to 15 years, because of usage of technology, because of usage of technology, usage of smartphones, and usage of internet. Usage of technology, usage of smartphones, and usage of internet. This data, the huge data which is being generated, uh, from where this data has been generated from where this data has been generated means mainly we see three sources of data. Three sources of data, right? Mm. Social data, machine data, and transactional data. Social data, machine data, and transactional data. Social data means data which got generated from the social sites like Facebook, Twitter, all this, right? Machine data, data which has been generated by reading or scanning the barcodes, RFID chips, all this. Transactional data like day-to-day operations like bank transactions, telecom transactions, right? So mainly these are the three main sources from where where the data has been generated from. And this 80% of the data what we see is going to take three formats, three types I can say. Three types of data you can see mainly, right? Like structured data, secondly like semi-structured data, yes, and unstructured data. Structured data, right, which is organized in the form of rows and columns in a structured format like Excel files, database tables, DB tables, right? And semi-structured data, which is not fully structured, which is not fully unstructured, right? Like XML files, JSON files, key value notations. Unstructured data, like short messages, articles, images, videos. Means today, if you see the data which has been generated from the last 10 years, the huge data is mostly going to occupy unstructured format. The biggest challenge today, storing and handling this unstructured data. Storing and handling this unstructured data, right? Yes. So if you talk about the databases, they can handle only structured data. But handling this unstructured and processing this unstructured data. So we have got Hadoop, which can handle all varieties of data, structured, semi-structured, and unstructured data. Now, as day by day, as data is increasing enormously, we need to have proper storage systems for storing and processing this data, right? So for that, we have got a framework like Hadoop. It is meant for two things. Hadoop is mainly meant for two things, for storage and for processing. Hadoop is meant for two things, for storage and processing. Talk about any technology, it is meant either for storage or processing, right? We talk like C or C++ or Java or .NET, all this they are meant for processing. Or if you talk about this Oracle, MySQL, DB2, SQL Server, all these are meant for storage. Means any technology either meant for storing or processing, but Hadoop performs both storage and processing. For storing, it doesn't use any database for storing its data. Rather, it's going with a special kind of file system, Hadoop distributed file system. We call HDFS, Hadoop distributed file system. We'll be discussing in brief about this file system. Okay, Hadoop distributed file system for storing Hadoop's data. And for processing, it is not using any technology like Java, .NET, or it's going with an execution model called MapReduce. It's going with the execution models like MapReduce, Spark, right? Clearly understand what are the services provided by Hadoop for storage and processing. For storing, we have got HDFS, and for processing, MapReduce or Spark. So if you take if you take big data, huge data generation, huge data, you take big data as a problem. You can say Hadoop is the solution, right? If you take big data as a concept, then you can say Hadoop as the implementation. Okay, nice. So you understood, right? Hadoop providing two services. storage and processing. Just observe Hadoop providing two services, storage and processing. For storage, HDFS, Hadoop distributed file system, and processing MapReduce. Most of you might be getting queries. If Hadoop is able to perform both storage and processing, then what is the necessity of this processing and storage technologies? When Hadoop performs both, is this technologies required then? If Hadoop in the market, then whether this technologies, you need to clearly understand Hadoop is meant for batch applications or batch processing. Hadoop is meant for batch applications, not for online applications. So Hadoop is meant for batch applications. What do you mean? So we have got two types of applications. Before I go with the advantages of Hadoop, there are two types of application. Hadoop is meant for batch applications. In a simple way, I say the two types of applications, online applications and batch applications. Hadoop is meant for batch. It is not for online applications. For a single record, Hadoop not required. You are making a single transaction, right? Hadoop is not required. For small data, Hadoop is bad. For huge data, Hadoop is. So online applications, user interactive applications, user gives the input. Here user gives the input, making a online transaction, booking a movie ticket. Example of this online application, user interactive application, user gives the input, making a online transaction, booking a movie ticket. User compulsory required. Batch application means user non-interactive application. Here user is no way required. Example of batch application, railway ticketing PNR status. For example, your waiting status like 200. After 1 hour, it became 150. Tomorrow morning, it became 100. Tomorrow evening, it got confirmed. Means it is happening in the background. Here, user is no way required without any interference of the user. And also examples like generating credit card statements for millions of customers. User is no way required. Phone bill statement generation, right? Yes. So here, user is no way required for millions and trillions of users. So Hadoop is for batch applications. And you may ask why databases like Oracle can't be used for storing Hadoop's data. What are the drawbacks with the current databases as compared with Hadoop? One by one drawback you observe, right? Most of the databases, right? Most of the databases, you see limited storage in GBs or in TBs. Limited storage and huge data storage is not possible within the databases. And secondly, in most of the databases, no parallel processing, no parallel processing in most of the databases. And also, if volume increases, right? If volume increases, speed decreasing, right? Just we'll see some example to it. If volume increases, speed decreases. In a database, if volume increases, speed decreases. For example, take an SQL query. Select a sum of amount, total amount from sales one. Select total amount from sales one. Total amount from sales one, right? Yes. Select total amount from sales two. Select total amount from sales to 1 lakh records. Sales one table has got 10 records. Sales two table has got 1 lakh. Sales three has got 1 crore, 1 crore records, right? If you observe from query to query, the volume increasing, right? Speed decreasing. Sales one has got 10 records. Sales two has got 1 lakh records. Sales 3 has got 1 crore records. Yes. Query to query, as the volume increasing, right? Volume increases, speed decreases. Which query executes faster among these three? Which query executes faster among these three means obviously the first query of 10 records. And if you see the other drawbacks of database, if complexity increases, speed decreases. If complexity increasing also, speed decreases. Total amount from sales one. Select total amount from sales one. Select average amount from sales one. And select standard deviation of amount from sales one. Total amount from sales one, average amount from sales one, standard deviation of amount from sales one. So which query executes faster among these three? You are applying that query on the same table, sales one, and sales one. Which query executes faster among these three? Obviously the first query, right? Because it is a one-step process, but average amount is a two-step process. Compared to the average amount is a two-step process. First sum to be calculated, next average has to be calculated. As compared to the first query, second query taking more time. As compared to the second query, third query taking more time because lot of internal processing required. Standard deviation means lot of internal processing is required. Query to query, even if the complexity increases, even the speed decrease. And the major drawback with the databases, right? Databases can handle only structured data. They cannot handle unstructured or semi-structured data. Databases can handle only structured data. They cannot handle unstructured or semi-structured data. Yes. Okay. See that it can handle only structured data. For example, the major drawback with databases handling only structured. For example, you want to take reviews for a particular movie. The table name reviews. This is the table. User and the review. The first person like user 1, user 2, user 3, so on 100 users, right? User 1 saying the movie is good. User 2 using the movie is bad. User 3 saying the movie is good. Means they are saying in the form of ones and zeros. That's they are giving feedback in the form of ones and zeros. Can you write an SQL query to count the number of ones and zeros? Select review wise count I want. Select review wise count I want from reviews. Select review wise count star from reviews. Single grouping and single aggregation. Grouping, okay, group by review. Review wise count I want from reviews table, group by review. Means the output. 1 and 0, the first person. So 90 people saying the movie is good, 10 people, 10% they are saying the movie is bad. Review wise count I want from the reviews table, group by review. But generally, review or feedback won't be given in the form of ones or zeros. They will be given in the own text format. First person saying movie is good. Second person saying movie is not good. They say they're giving the feedback in their own text format. Can you write an SQL query to say how many people saying it's good, how many people saying not good? Even if you want to compute by using the keyword count, even it gives wrong computation because even not good has got good within it. Yes. So major drawback with the databases. Databases can handle only structured data. Complexity increases, speed decreases, volume increases, speed decreases, limited storage, no parallel processing in most of the, yes. See, I'll just give an overview, like Hadoop follows master slave architecture. It won't follow client server, right? Hadoop doesn't follow client server architecture. It's not for Hadoop is not for request response architecture. Whenever user giving the request, giving the response, that kind of architecture. Hadoop doesn't follow client server architecture. It follows master slave architecture, single master and multiple slaves, single master and multiple slaves. Observe, Hadoop follows master slave architecture, single master and multiple slaves. So group of systems connected in a network, we call it like a cluster. This we call it like a cluster, Hadoop cluster, right? Group of systems connected in a network. In that group of systems, one will be the master, all the other will be the slaves. We talk about in Hadoop, data is stored in the form of file, txt files. In database, it's stored in the form of tables. Think that each system capacity 1 TB, 1 TB, 1 TB, 1 TB. But f1.txt, the size is 2 TB. It cannot fit into any of these systems, right? So in case of Hadoop, the file will be splitted into smaller parts. Each part stored across the each part stored across this. So data is distributed across multiple systems and are processed by multiple systems parallelly. That's why we see very high speed processing. Data stored across multiple systems, stored across and processed by multiple systems parallelly. So advantages of Hadoop. Yes. So before that, right, what is the master node responsibility, slave responsibility? Master assigns task, T1 task to S1, T2 task to S2, T3 task to this, T4 task to this. Assigning task and load balancing, the master node responsibilities. So group of nodes connected in a network, we call it like a cluster. There are two types of nodes, master node or slave node. We have got two types of nodes, master and slaves. Master node responsibility, assigning tasks to the slave, balancing the load equally to all the slaves. Fault tolerance means during the execution, suddenly if any slave goes down, any system goes down, then that task has to be assigned to any of the other system. Who does this? Master only. Health monitoring, before assigning a task to the any of the slave, first it checks their health status. And slave load responsibilities only to storing data and secondly processing data. Advantages of Hadoop. Next, advantages of Hadoop means first thing is unlimited data storage is possible. Unlimited data storage is possible in Hadoop. Unlimited data storage is possible, right? Yes. Very high speed processing. This is advantages of Hadoop. Unlimited data storage. It has got a feature, right? Unlimited data storage. Horizontally unlimited scalability. Means unlimited data storage is possible because of a feature. Horizontally unlimited scalability means horizontally unlimited number of slaves can be added. Tomorrow, like if your uh, customers are increased, your branches are increased, means your data is increased. That is, customers are increased, means data is increased. Means you cannot go with the same number of systems. Horizontally, you will keep on increasing your systems for storing data. And very high speed processing because of parallel processing. And one more advantage is Hadoop can handle all varieties of data, structured, unstructured, and semi-structured data. And it is an open source, no licensing required. Most of these Hadoop products we are going to download from the Apache Mirrors site. Apache Mirrors, right? Yes. And commodity hardware, no need of highly configured systems. It can run on any hardwares, right? This Hadoop can run on any hardware. Okay, mainly unlimited data storage is possible. Very high speed processing can handle all varieties of data. Open source, no licensing required. Hadoop advantages. Next, Yahoo, right? Yahoo has it's performed a test. It has performed a test to check the speed of various databases. It has taken a table. It has taken a table of 100 TB. It has taken a table of 100 TB consisting of 1024 columns. Consisting of 1024 columns. Task sorting based on 16 columns. Sorting based on 16 columns. What is the time taken by the different databases? Oracle has taken 3.5 days to process this 100 TB data. MySQL has taken 6 days to process. Teradata has just taken 4.5 hours. Teradata has just taken 4.5 hours, right? Say specialized database used for data warehouse, right? And Netija is one more specialized database used for data warehouse, right? That's taken 3 hours. But finally, Hadoop PC has just taken 3.4 minutes. See that days and hours, but Hadoop has taken minutes of time. Latest version of Hadoop just taking 1.2 minutes. Why databases like Oracle? Why databases like Oracle won't support unlimited storage? Why only Hadoop can perform unlimited storage? Why databases can't perform unlimited storage means for databases there is some limitations. In real time, even for databases, we can go for different number of slaves systems, right? Observe why databases like Oracle can't support unlimited storage because this databases and max limit on the number of systems or slaves. Oracle can go maximum with 256 systems or slaves, right? MySQL also. MySQL has got 54. can go max of 54, but MySQL Express, right? Where it can go with 256. DB2 SQL Server, all this they can go max with 256 slaves. But some specialized databases like Teradata can go with 512. Netija also 512. Vertica also 512. But currently Teradata is supporting 1024 slaves. Even Netija also it's going with 1024 slaves for storing its data. See, for these databases, there is a limit to go with these many systems or slaves. But in Hadoop, there is no limitation. Observe. But there is no limit on the number of slaves that Hadoop can have. It can go with unlimited number of slaves. And if we see that storage point of view also, right, Hadoop is proven in the market. Yahoo. See this Yahoo when first time implemented Hadoop. Yahoo when first time implemented Hadoop went with 4,000 slaves for storing its data. Currently, Yahoo going with 12,000 slaves for storing its data. Yes. Facebook, when first time implemented Hadoop, went with 8,000 slaves for storing its data. Currently, Facebook going with 42,000 slaves for storing its data. Means not only like 256, right? It can go with 4,000, 12,000, or 40,000, right? 50,000. No limitations on the number of slaves. Okay. And what are the components I'm going to Hadoop ecosystem components? We have got some storage and processing components. What are the things I'm going to discuss as part of this course, right? First, some storage and processing components like HDFS for storage, MapReduce meant for processing. Even for Apache Hive, we are using it's a kind of data warehouse kind of environment in the Hive in this Hadoop framework. So here we use a language called HQL, Hive query language, similar to SQL, right? And we discuss about a component called Scoop, SQL plus Hadoop. The first two characters of this and last three characters of X. Means we use for import or export. Yes. The first two characters of this and last three characters of this forms scoop used for what? Import or export means bringing data from other environments to Hadoop environment, that is importing, and exporting data from Hadoop to external sources like databases. NoSQL, not only SQL. In the case of SQL, structured, right? From first record to last record. Same number of columns has to be maintained. But in NoSQL, first record with 3 fields, second record with 5 fields, third record with 7 fields, right? Record to record different number of fields can be maintained. And schemaless behavior. Okay. We are going to discuss one NoSQL database HBase. Yarn, yet another resource negotiator. In Hadoop 1 version, 2 versions, we are in Hadoop 0 and 1 versions, we got some drawbacks. But from Hadoop 2 version onwards, all that errors have been rectified. We say like Yarn, yet another resource negotiator. Zookeeper for controlling and coordinating all the other Hadoop components. Flume Kafka. I also provide you the knowledge on Flume Kafka, like streaming data, streaming technologies. These are Flume and Kafka are streaming technologies. They are used for streaming data. What do you mean by streaming data? Data which keeps on incrementing, data which keeps on generating. Live streaming data, we say, right? Which keeps on generating, which keeps on incrementing. Such kind of data, we call it like streaming data, even capturing that kind of data using tech Flume and Kafka. Yes. And finally, right, the major part of our course, PySpark, right, just got very great boom in today's market. We have got a high boom in today's market, like PySpark, right? Like Spark Code, Spark SQL, and Spark Streaming, right? This is going to be discussed, right? So if you see that course structure, yes, we'll be discussing in brief, in depth about all this data engineering, like Hadoop and Spark, right? So here, starting with the big data, yes. What is big data? Why Hadoop? Need for Hadoop, sources and types of data, comparison with other technologies, challenges like databases, advantages, Hadoop ecosystem components, HDFS, Hadoop distributed file system, features of it, HDFS architecture, name node, data node, metadata management, storage and processing, right? Replication, right? Next, MapReduce. MapReduce is a execution model, right? Parallel execution model designed for parallel processing, like what is the job tracker, task tracker, mapper face. So yes, entire thing of this MapReduce and the scoop SQL plus Hadoop for importing or exporting data from databases to this Hadoop environment, performing different kinds of transformations while importing itself. Before data importing, we can perform different transformations, filtering operations, merging operations, working with delimiters, groupings, aggregations, loading, incremental loading, all this we can perform. Next, Yarn, yet another resource negotiator, right? You need to know about the entire architecture of it, what's happening and how this is getting processed. NoSQL databases, what are the different types of NoSQL databases, the differences, and one NoSQL database like HBase in brief. And coming to that important component of Hadoop, right? Hive, Apache Hive, we say, it's a kind of data warehouse kind of environment in the Hadoop framework. Just we have got jobs only on Hive, right? If you have got good command on it, like loading data from local, from HDFS, in internal tables, external tables, working with unstructured data, working with XML data, working with JSON data, with URLs and weblog data, and merging and inserting into HDFS, UDF, UDF, right? User-defined functions, user-defined aggregated functions, user-defined tabular functions, partition table, non-partition tables like multi-column partitioning, dynamic partitioning. And coming to the PySpark, the major area what we discussed, right, as part of our course, like what is Apache Spark, need for PySpark, features, and sessions, Spark session, Spark context, parallelizing, repartitioning, broadcast variables, accumulators, right? Yes. PySpark RTD computations, operations on a RTD, directed acyclic graph, RTD actions and transformations, RTD computations, steps in RTD computations, persistence options, memory only, memory underscore SCR only, disk only, PySpark core computing, right? Right. Fault tolerance model, different ways of creating and increasing the number of partitions, aggregations over structured data. Groupings and aggregation, single grouping, single aggregation, multi-grouping, single aggregation, multi-grouping, and multiple aggregations. Differences between reduce by key, group by key. Yes. Various inbuilt actions and transformations of PySpark, all this, and PySpark SQL data frames means you can see that PySpark show row, select, collect with column, column rename, drop, group by John's, union map, flat map, fill nulls, SQL functions, aggregated functions, window functions, date and timestamp functions, JSON functions, read and write JSON file. And inbuilt functions, we have got many inbuilt functions one by one with many working examples. Split, translate, replace, to date, explode, array, correct list, map keys, map values, struct, row, all this, right? And PySpark external sources, working with SQL statements, Spark and Hive integration, Spark and MySQL integration, working with CSV, working with JSON, transformations and actions on data frame, narrow and wide transformations, adding of new columns, dropping of columns, renaming columns, adding of new rows, dropping rows, dropping nulls. Deployment modes, local mode, cluster mode, and PySpark applications creations like drivers, stays, and tasks, driver executors, deploying applications and pipelines, Spark applications to cluster and tuning, performance tuning, PySpark streaming concepts, integrations with Kafka and PySpark, ML machine learning library, right? Yes. So here, as part of this course, you'll be learning these things. One second. Hadoop, PySpark, Linux, and Python also, right? So it's a package. The fee structure is 15,000 for it, which covers nearly like 60 hours of Python course. So even this Python, okay, means for PySpark, you need to have the knowledge of Python. So first we'll be discussing Hadoop. Meanwhile, you people will can attend any of my Python batch that will which goes in Monday to Friday. You can attend any of my Python batch, means for 60 sessions will be there on Python core and advanced, in which because you should be good in Python codings. So the total implementation or the total coding goes in Python, right? PySpark. So yes, as of now, right? Coming Friday, morning and evening batches are available for Python, right? Coming Friday, like at 8 a.m. in the morning or evening at 7 p.m. it is there. Same that day, coming Friday, right? At 7 p.m. in the evening. Oh God. Not only this, there are other batches also in Python which is going to be started. You can attend any of my match of Python. So Python, Linux, PySpark, Hadoop, this is what. If you doesn't want, if you already got knowledge in Python without, okay, if you want only Hadoop, PySpark, and Linux, the fee will be for these things. The fees will be like 12K. So with Python, like with 60 hours course of Python, and this Hadoop and PySpark, and this everything will be on weekends only, on Saturday and Sunday only. Saturday and Sunday. Let me make it clear about the timings, right? See, there were many requests given by the students, especially from the students from the US time zone. Actually, they are not able to attend the demo today because of this. It's 1 o'clock means 1 p.m. for them. It is midnight 3 p.m. for midnight 3 o'clock for them. So people they have got many requests. So I said for the first 2 weeks, as it is the batch is already announced. So for the first 2 weeks, that and let me make it clear about the timings. For the first 2 weeks, it will be at 1 p.m. Later, after this week and next week, it will be at 1 p.m. But later, it will be in the timing of this batch will be 4:30 p.m. in the evening. Starts at 4:30 to, yes, 4:30 to 6:30 p.m. in the evening. We're open to all the students, right? Yes. 2 hours on Saturdays, 2 hours on Sundays. Totally, you will get 4 hours per week, and those who are attending Python can attend it. So totally, it goes for 12 weekends. 12 weekends means it goes for 3 months in brief about all this. Yes. And what you are going to get the offerings from our side, right? You'll be getting even if you miss any of the session, right?
Sorry for
1 second, let me complete just what I'll take 2 minutes. Later I'll go with your general queries, right? So you may think as these are weekend batches and people from who are doing jobs and people, some students also will be attending. If you miss any session, not a worry. So every session video you'll be getting that day itself. Today, for example, today we have completed the session, right? After within 2 hours of time, you'll be getting the video of your Google Drive. Every session video, every session is recorded. You'll be getting the recorded video. Yes, to your Google Drive, right? Clear soft copy of the notes, class notes. Clear soft copy of the notes you'll be getting, right? And tasks, working with some assignments tasks. And for technical discussions, or if you get any errors, right? A WhatsApp group will be created, right? For technical discussions. If you got any error, you can just take the snap of it and you can post in the group so that it will be answered by any of one. I'll be answering it. Yes. Fine. If you got any queries, right, you can go with your queries now. Yes.
Hello, my name is Yugandhar. I have a doubt in Python. How many you can take Python every day? 1 hour, 60 classes you said, right?
1 hour, 1 hour, 1 hour, right? Python class, Monday to Friday, it will be daily, it will be for 1 hour.
When? Daily 1 hour means which time?
So 1 second. So yes, 1 second. Coming the date. On 16th, Feb 16th, right? February 16th, a new batch going to start at morning 8 a.m. On the same February 16th itself, on
Okay.
evening 7 p.m. also there will be one more batch. So morning and evening both are available if anyone who wants to prefer morning or evening. Yes. Feb 16th means coming Friday, right? Means daily 1 hour,
Okay.
daily 1 hour the class will be, right? So yes, and if anyone not fine with the timing also, recently a batch got started just 4 5 days back. At morning 6 a.m. there was a batch started just 5 days ago, right? Even if you want early morning session, right?
Only,
Yes. Okay.
only Python, how much this one total classes?
Python nearly you will be have 60 hours, right? 60 hours, 60
Oh,
sessions on that.
uh, how much cost will be that one?
Only Python it is 6,000, right? Yes. Only Python it is 6,000. Yes.
Okay.
Yeah. And okay, fine. So this is what the entire package. It's 15,000, which includes Hadoop, PySpark, Linux, and Python. And excluding Python, right? It means if you already know Python, if it doesn't want Python, it is 12K. Fine. So yes, any other queries from your side? Anyone? Yes.
Thank you.
Okay, tomorrow also you can attend the session, right? Same time at 1 p.m. Possible to learn project with Hadoop database. Yes. Yeah. So yes, tomorrow also you can attend the session same time at 1 o'clock to see more on this, right? How exactly the data storage and processing is happening within the Hadoop. So tomorrow you can, and tomorrow also you can attend the session, right? Tomorrow I'll be start with the technicals of this Hadoop, right? Basics of Hadoop I'll be discussing. But from next week onwards, next week also it will be at 1 p.m. only. 2 hours on this, next week, 2 hours Saturday and 2 hours on Sunday. But next Saturday, the link will be changing. Tomorrow you can attend, right, with the same link, same time. Next Saturday, the link changes. So you can see that the online team, they have forwarded the details about this, contact details of that. If you have got any queries, you can just contact that. The contact details are provided. Yes. And the payment process procedure, the course content, right, for only Hadoop, PySpark, Python, and Linux, right. And the payment process and procedure, right. Yes. Yeah. Fine. Any other queries, right? Anyone? So everything 100% will be understanding. There is no, or don't for software. I'll be providing you the software where you can see all this Hadoop to work with Hadoop and Spark. Not a worry about the software, right? And the sessions will be interactive sessions. You will be kept in unmuted status. At any point during the session, you can ask the queries, right? And even if you've got queries related to the previous topic, at the start of the session, you can ask, right? As I said, there'll be a technical discussions. WhatsApp group is available, right? Yes. Yeah, fine. So if I'm done with your queries, if there are no other queries, I will sign off for now. Meet you tomorrow, same at 1 p.m. to see more on this. Fine. Yes. Thank you all for your time. Thank you. Meet you tomorrow.